Okay, so this is the first lecture for Math 113, Angles and Trigonometric Functions. This covers sections 4.1 and 4.2 in the book, and the book is available in my math lab. So what is an angle? An angle is determined by two rays, right? And so a ray starts at a point and goes off. If we have two rays like this, there's an angle T. This one is a positive angle because it goes counterclockwise, right? This way. If I have two rays and an angle, I usually don't put the arrows at the end of the rays. We went this way, that would be a negative angle. We usually call angles T or theta. It's the Greek letter theta. I suppose I should write that down. Okay, so angles can be put in standard position, right? You can draw them all over the place, but a standard position for an angle is, here's my x-axis and my y-axis, is to have one ray be the positive x-axis, and then the two rays meet at the origin. So an acute angle is one that's 90 degrees. A right angle is 90 degrees. An obtuse angle is one that is, we have this whole angle, theta, that's obtuse. And a straight angle is 180 degrees. So that's four types of angles. We're not going to be using that language very much. How are angles measured? You can measure them in degrees and radians. You're probably familiar with degrees. Radians are connected to circles. If we have a circle and a center with radius r, then if we construct an angle so that this length here along the circle is also r, then this is 1 radian. And that's the definition of a radian. So 2 pi radians corresponds to 360 degrees. A distance along the circle is an arc, right? So this is what an arc of a circle is, up here where this r is. And usually we use letter S to stand for the length of arc. So what do we have? If a circle is radius r, the relationship between arc length S and angle T is S equals R times T. But T has to be in radians, not in degrees. So if a circle has radius 3 inches, what's the measure in radians of the angle T that yields an arc of 6 inches? So what we're asking is, here's a circle. Its radius is 3. And we want an arc of 6 inches. And what is that angle that we need? And so our little formula up here tells us that 6 is going to be 3, because that's the radius, times T, where T equals 2 radians. And you can convert radians to degrees. There's 2 pi radians in a circle, because the circumference of an entire circle is 2 pi r. And there are 360 degrees in a circle. So if T is 2 radians, that means we must have 2 over 2 pi equals x over 360, where x is the measure of the degree in angles. I can cancel my 2's, multiply both sides by 360, get 360 over pi is my angle in degrees. And if you divide that out on your calculator, you get 114.59 degrees equals x. And you know, there's more decimals there. And so that's how we can convert between radians and degrees. So how do we convert 54 degrees to radians? Well, 54 is to 360 as T is to 2 pi, and we want to find that for T. So I know I can simplify 54 over 360 a little bit. I know that 5 plus 4 is 3, 3 plus 6 is 9, so the top and bottom are both divisible by 3, and that would give me 18 over 120. And I look at that, top and bottom of both divisible by 6, and that would give me 3 over 20. And that's simplified. So this is 3 over 20 equals t over 2 pi. Multiply both sides by the 2 pi, you get 6 pi over 20 equals t, or 3 pi over 20. So 3 pi over 20 is what this angle is. It's 54 degrees. Usually we leave the pi there because this is telling me it's 3/20 of pi. Pi over 7 radians to degrees would be pi over 7 is my degrees, and that's to 2 pi as x is to 360. So I want to simplify this a little bit. I'll multiply both sides by 2 pi first. No, I'll multiply both sides by 360 first. Oh, and that's a 7 under there, pi over 7. Okay, so can do a little bit of simplification here. This 2 can cancel out of that. And remember, if I have this fraction times this divided by pi, that's going to be 180 over pi times pi over 7. So the pi's will cancel out. So x is 180 over 7 degrees. And do I have that written down here? It should be about 82 degrees. I didn't have that written down. 25.72 degrees, actually. So drawing both angles in standard position. Where are these things? Well, 54 degrees, that's less than 90 degrees. 90 degrees is this angle. So 54 degrees would be about here. 25.72 degrees, that's less than 90 degrees. It's also less than 45 degrees, which is sort of the diagonal there. So it's going to be down here a little bit. 5 over 7 radians. So we can draw them. They're both acute angles. So unit circle. The unit circle is a circle of radius 1. We use it a lot. And there's batches of angles that we're interested in. We have 4 quadrants. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. The x-axis itself is 0 degrees or pi. No, not pi, or 0 radians. A right angle is 90 degrees or pi over 2 radians. So all the way around the circle is 2 pi. So a quarter of the way around the circle would be 2 pi divided by 4, which is pi over 2. 180 degrees or pi, that's the straight angle, and then down this way, 270 or 3 pi over 2. So those are basic 90-degree angles. 45-degree angles is another set of angles that we are interested in. 45 degrees is 1/2 of 90 degrees. We know that 90 degrees is pi over 2 radians. So 45 degrees would be 1/2 of pi over 2 is pi over 4 degrees, pi over 4 radians. So if I draw a unit circle, right, we want pi over 4. One way to keep in mind is that pi is 180 degrees, so it's up to here. So pi over 4 means I want 4 angles between 0 and pi over 4. So 1, 2, 3, 4. And then I need 4 more in the bottom. 1, 2, 3, and then 4. And that gives me 8 angles for the full 2 pi. So 1, 2, 3, 4, 5, 6, 7, 8. This is pi over 4. This is 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. And this is either 0 where we start counting, or it's 8 pi over 4. Some of these can be simplified. 2 pi over 4 simplifies to pi over 2. 4 pi over 4 simplifies to pi. We're happy with that. 6 pi over 4 is 3 pi over 2, which is what we had up here. And then 8 pi over 4 is 2 pi, so that's what's around the circle. So the denominator tells you how many angles you have to have in the top, 4, and then how many more in the bottom, 1, 2, 3, 4. And that gives you the 8 angles that you need. 45 degrees, 90 degrees, 135, 180, 215, no, 225, 270, 315, 360, if you go around by 45s. 30 degrees, oh, I should have left myself more space for this. Unit circle again. 30 degrees is 1/3 of 90 degrees. And we know 90 degrees is pi over 2. So what's 30 degrees in radians? It's pi over 6. So we need 6 angles in the top. 1, 2, 3, 4, 5, 6. And I need 6 in the bottom. 1, 2, 3. This is supposed to be the y-axis. 4, 5, and then 6. So what are the angles we have? 0, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6 over here, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6 down here, 10 pi over 6, 11 pi over 6, and 12 pi over 6, and 12 pi over 6 is 2 pi, and so we've made it all the way around the circle in sixths. This is pi over 3. This is 4 pi over 6 is 2 pi over 3. 8 pi over 6 is 4 pi over 3, and 10 pi over 6 is 5 pi over 3. So the angles that are by 6s, if you go by 2s, right? 2 6 is 1/3. 1 2 4 6 is 2/3. 3 6 is no, 6 6 is 1/3 is 1, and then 8 pi over 6, and then 10 pi over 6 is counting by 3s. So what about, where's the 13 pi over 4? So angles on the unit circle are between 0 and 2 pi. 13 pi over 4 is 8 pi over 4 plus 5 pi over 4, which is 2 pi plus 5 pi over 4. So on a unit circle, what's going on there? Here's my unit circle. The 2 pi says go around the circle once. So we go around the circle once. And then we have to go another 5 pi over 4. So how far is 5 pi over 4? Again, the denominator is 4. So we want 1, 2, 3, 4 angles in the top, and 1, 2, 3, 4 angles in the bottom. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. This is 5 pi over 4. It's down here. Great. So what's a negative angle that's coterminal with that? Well, 5 pi over 4 is going this way around the circle. If I went this way around the circle, I would have a negative angle. That gives me the same angle there. So what's this angle? Well, 1, 2, 3. So it's minus 3 pi over 4, the minus sign because we're going in that particular direction.